my name is Karen.
I'm Michelle.
And our topic is buoyancy.
And a buoyant force is the upward force created when there is an increase in pressure with increasing depth.
And a principle that goes along with buoyancy is Archimedes' principle. It states that an object immersed in a fluid has an upward force on it that is equal to the weight of the fluid displaced by the object. In simpler terms, that means that the density of water, if it is greater than the density of the fluid, the object will sink. If the density of the water is equal to the density of the fluid, it will neither sink nor float. And if the density of water is less than the density of the fluid, the object will float.
And we have a few examples. Here's a rock. And we put that in, and it sinks, so the density of water is more than density of fluid. And then we have a water balloon filled with water.
Whoa! That's really cool!
And since it doesn't sink or float, then the densities of both water and fluid are equal. Then we have an ice cube. And that floats, so the density of water is less than the density of fluid.
And if we want to know more about the buoyant force of an ice cube, we can just use the equation that goes along with buoyant force. Let's do that next. This is our formula for buoyant force. It starts with the density of the fluid, and then we multiply that by the volume of the object, multiplied by the acceleration due to gravity. For our example of the ice cube in the water that floated, we will use the density of the fluid as 1 times 10 to the third kilograms per meter cubed, since it's water, and then the volume of our ice cube was 1 times 10 to the negative fourth meters cubed. And then, of course, acceleration due to gravity is just 9.8 meters per second squared. And once we multiply all of that together, we get our answer of 0.98 newtons.
The weight of the ice cube is 0.88 newtons, and the buoyant force is 0.98 newtons. And since the buoyant force is greater than the weight of the ice cube, then it concludes that the ice cube floats. Now we're playing Guess the Density.
Sink or float. Our first object is an egg. Our second object is a piece of bread.
Our third object are gummy bears. Our fourth object, Target name tag.
And our fifth object is a giant ice pack that looks like an Oreo. Back to our first object, the egg. Will it sink or float? Any guesses?
Sink, float, sink, float, sink.
Oh, it sank! Our next object, the bread. Any guesses?
Float, float, sink, float, 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 float.
Oh,
hey!
It floated!
Sorry.
Next we have the gummy bears. What's going to happen?
Sink, float. Oh.
Oh, they sank.
And next is the name tag.
Oh, what's happening? Oh, it sank. Last we have the giant Oreo ice pack. Since the ice cube floated, do you think the same thing will happen?
Yeah, maybe. I don't know, but yeah.
Oh, it floated. What a shocker. See you back next time on Sink or Float.
Just keep a hold of me, don't let go. If you float away, if you float away, we ain't too long for a ship to come. Don't you float away, don't you float away.
Cube floated. Will an ice pack float? Oh, wow! It floated! It floated!
You can't.
We need to start over.
I'm gonna stop.
Our first object, our first three. Okay, can we just restart?
You want Family Guy in the background? Or?
Yeah. This is the. Oh, hang on, I have to get close. This is the formula for the buoyant force. Sink or float. Oh, looks like it sank. Next object is the bread.
That egg shrinks really fast.
Kilograms per meters cubed. Because it's water, we just do simple water. And then the density of our ice cube was 1 times 10 to the negative 4th meters cubed. And then we multiply that by the acceleration due to gravity, which is 10. Luke!
What?
We're filming.
Sorry.
That's okay. So first, we'll start with the egg. Does it sink or float?
You know what makes me really happy?
What?
I'm getting the ice.
Yes. This is a secret weapon.
Oh yeah. Next are the gummy bears.
Wait. Looks like that one floats.
Ew.
Okay.
That was so good, Karen.
We leave the bread there because it's disgusting.
I know we need to bread
Okay.
new gummy bears, maybe. I can't.
Oh, gross.
I told you.
For our example of the ice cube, we use okay. Sink or float? Oh, looks like it sank.
Karen.
And since the buoyant force is greater than the apparent Earth shoot.
Oh, okay, I'm not gonna stop it. I'm gonna pull one of you.
Oh no, that's not okay. Now I gotta erase it. I told you it would be right there. And then,
First object is an egg. Our second object is a piece of bread. Our third object is a giant Oreo that just happens to be filled with ice.
I can't go after that.
Gross.
What, are you hiding me?
Yes, it's our secret weapon.
Gonna pull these out of nowhere?
Yes, bam. Oh my God. Not a lemon.